objects and classes today. So we've seen objects in Scala. We're going to expand that and talk about classes, which are ways to create new objects. So the lecture question today, it's going to be kind of a two-parter. It's going to be 20 points. This is a way for me to get more lecture question points out there so you can make up for ones you missed. Some of them will be worth more. Since it is worth more and it is a decent amount more work and a lot of concepts that we're digesting, this will be due Sunday at midnight instead of tonight at midnight. And I'll probably do this whenever there's a double pointer. I'll just have the due date a little later. Partly because I want to give you more time to work on it, but also this isn't really one you can skip. For the homework, for the physics engine and all the homeworks, you'll need to understand how this one works to be able to get that homework. So I don't want anybody skipping those concepts, and then setting yourselves up for failure on the homework. I really need you to understand these concepts so you get that content in there. So I'll give you more time, make sure you get it done, and make sure you understand what's going on here with the objects classes and testing classes, references, methods with side effects, methods that return unit but actually do things. There's a lot of stuff going on here that typically trips students up, so I want to make sure everybody gets these things down. So create a class called score, has one field, member variable, etc. We'll get into that, called score, that is set through a constructor. One method that returns unit but has the side effect of incrementing the score by 1. And one method named isWinner that takes another score as an input and checks which score has a higher score variable inside of it. So if this score is larger than the input score, return true, then false otherwise. So ties is a loser for the calling object. And then a test suite to be able to test these objects. And this is probably the bigger one for the homework. How do I test these objects? This is a big question each semester, each time we talk about classes. How do I test a class? Or rather, objects created from a class. How do I test that? So we'll talk about all that. So first, let's review objects a little bit and add a little bit more vocab, a little bit more nomenclature around this. An object has state and behavior. So the state is a set of variables that control, as it says, the current state of that object and the current values of those variables stored in that object. It also has behavior, which are the functions that are part of the object. So an object is a container filled with variables and functions. When we put a function inside an object, we call it a method, just because it's got to be different. The actual difference between a method and a function is a method takes implicitly a parameter which is a reference to the calling object. If you've done classes in Python, this is a little more explicit, where the first parameter of every method is always self. If you've seen that, that's what's going on there. That's because those are methods instead of functions, and Python makes that a little more implicit, that a method contains a reference to the calling object, where functions do not. So we saw an object. This is a different one, but we've seen objects before. If we have any variables outside of all the methods in an object, those are going to be part of its state, the state of the object. We can access the state within an object using the keyword this, and then accessing those state variables. This is always a reference to the calling object that is accessible in every method. We haven't quite talked about this. This is true for all variables that we declare. But let's make this one explicit. If we declare a variable using val, that variable is now a value. It's not technically a variable. It's a value, which means its value cannot change. It's one fixed value. And if you try to modify the value of a value, you're going to get an error. You're going to say it can't reassign val, and you're going to get a compiler error. Your code isn't going to run. If we declare it with var, that means these are variables, and the values in the variable can change or vary, as the name implies. These variables can vary the values. So we're going to declare these with val and say that this x and y can change. And these variables inside objects go by many names. This may cause a little confusion, so I want to try to clear this up front. These go by many names, depending on who you're talking to. For me, I'll use these interchangeably. I'll try to stick with state variable in this class, but these go by many names. If you hear member variables, instance variables, or fields, these all refer to the same thing. It means it's a variable that's inside of an object. So it's either, in the names, it's a member of that object, or it's part of an instance of an object, which will make more sense when we talk about classes. You instantiate objects from a class, and each instance gets its instance variables, is where that naming comes from. Fields, I honestly don't know where that name comes from. And then state variables, which I like to use because it emphasizes that the variables are part of the state of that object, and that the state of the object can change. When I say it that way, it doesn't make so much sense for vowels, but I like that, keeping in mind, reminding you that that's the state of the variable, and that's really the point of having objects, is that objects have state. That's one of the big, powerful concepts of objects, is the fact that it has state, that those variables can change. And when we access this code, anybody with access, any piece of code with access to this object can access its state and behavior using this dot operator or dot notation or an access notation. Whatever you want to call it, it's this little dot here is going to take an object or a reference to an object and access some of its state or behavior. So here I'm accessing its double X method. Doesn't take any parameters and returns nothing, but since it's a method, it has access to the calling object through the keyword this and can modify its state. So when I'm calling this method, it's modifying the state variable x, and then when I print out, I can access the state variable x directly and print that to the screen, and of course this will print 20 to the screen. So I have a method call, took no parameters, took no arguments, didn't return anything, but it did have an effect on my program. Yep. Correct. So let me see if I got what you're saying. If I called double X twice, if here I just duplicated this line and called it twice, it would print 40 to the screen. So this dot X is taking the current value of X, which after I call double X once is going to be 20. So it's going to be 20 times 2. Oh, and I meant to mention, I'm using some new notation. I'm going to throw some more tricks and notation at you in 116 that we try to not scare 115 students with, but a lot of you end up using this notation anyway in 115, so I'm going to start using it. This is the same as this dot x equals this dot x times 2. So I'm multiplying this variable by 2 and then reassigning it to itself. So with that, did I answer your question at all in there?
I just don't really know what the purpose of this is.
So this, I could technically omit this and just say x star equals 2. This is making it explicit that I'm accessing a state variable. So if I could just say x star equals 2, and Scala will figure it out. It'll say, you must mean this x here because there's only one variable named x in the current scope. So we'll be able to find that, but I like having this dot to make it explicit. I'm modifying a state variable. So anybody glancing at this code knows that this method is modifying the state of this object. So not strictly required, sometimes it will be though. For example, if I had an input parameter named x, I would have to say this dot x to specify which x I'm talking about. Every value in Scala is an object. Everything, everything, everything. If you're coming from Java, you know everything's defined as classes, and you use classes to instantiate objects, and everything's an object. And you may have heard this about Java. If you're exposed to that world, if you took AP AP Computer Science or somewhere else where you've seen Java. But this isn't strictly true for Java because there are primitive values, the ints, doubles, longs, chars. These are all not objects in Java. This isn't true for Scala. In Scala, everything is an object. Everything, our ints, that's a capital I, that's our way of saying that's an object. Our doubles, that's a capital D, that's our way of saying it's an object. Every single thing is an object in Scala. Even technically, the classes that we define are stored as objects, storing the definition for that class. Everything is an object. Some of the objects, we'll see next week, some of the objects do behave like primitives. We'll talk about that next week, but everything in Scala is an object. If we have access to anything, it's an object. One of the implications of this is we can call methods on every single value in our program. You can write the literal 5, just the character 5, dot, and then access all of its state and behavior. So you can say 5, for example, 5.min 4 is going to return 4. It's going to call the min of those two ints and then return that. So you can call methods even on literal values, strings. If you just type out a string and say dot, you can modify that string immediately. There's not too many cases where that's useful, but just know everything's an object. You can, in IntelliJ, whatever value you have, put a dot right after it, and IntelliJ will show you all the stuff you can do with that value. Everything in Scala is an object. Every value in Scala is an object. So with that, we don't always want to just define objects, though. We don't want to create a new file and say, here's an object, it's going to store this kind of stuff, and I'm going to modify these variables and call this state. What we often want are a lot of objects of the same type. We want a lot of objects with the same behavior, or at least similar behavior, the same type of state with different state values, but the same type of state, very similar state and behavior, but just create a lot of them. So think like enemies in a game. We might want a lot of enemies. They might all be separate objects, but we're not going to define every single one of them independently. What we do here when we want this is create a class which is going to be somewhat of a template, which is going to allow us to create those objects. So if I define a class, I'm going to define the state and behavior in that class, and then I'm going to instantiate objects from that class, and the objects are going to have that state and behavior, and then I can instantiate many objects of that class type. So here's an example of a class. It's going to represent an item in a store. I just want to track a few things. The description of this item, which won't change, so I'm going to store that as a val. The price of this item, which might change, so I'm going to store that as a var. The number of times this was purchased, which I'll talk about why that's somewhere else and why those other variables are up in the top line there. The number of times this was purchased, which starts at 0, and then I'll increment each time it's purchased, and then a few methods to give it some behavior. I can either put this item on sale, or I can say, hey, somebody purchased one of these items, let's increment that for our stats so we can do our bookkeeping at the end and our inventory at the end of the month or whenever we're going to do inventory next. So this, in the rectangle right here, is the same as how we defined an object. So this is what we're familiar with. Every item is going to have a variable named times purchase, which is an int, which is initialized as 0. And every item is going to have these two methods. However, when I create a new item, not every item is going to have the same description and price. Those two things will be different based on which type of item I'm creating. So I want to make those a little bit different, and when we want to do that, we put that in what's called the constructor of the class. So the constructor is a very special method which is called whenever we create an instance of a class. So when I want to use this class to create an object, I'm going to call its constructor method, which is defined in this top line, what we call the header of the class. So class, give that type a name, and then a parameter list, just like we would see for any method. which says these are the arguments, these are the parameters, you'll give them to me as arguments when you instantiate a new item. You need to tell me these two values. Give me a description and a price, and I'll create you a new object of type item. And there's three different ways we can declare these variables. We can either use var, makes it not only variable, but also accessible outside of this class. This means that any code that has access to an item instance can change its price at any time. It can say whatever I name my item dot price equals, and override that or access it dot price, print it out or whatever. Val, similar, except you can't change it just like any other val. You can't change the description once you create an item. You only got one chance to set the description is when you call the constructor. But you can access the description from outside of this class. You can say print line, whatever my item name is, dot description, and I can access that and print it to the screen. The third option, which I'm not showing here, which we probably shouldn't use very often, there's some cases to use it, is not using val or var. If you don't use either of them, if you don't declare your variables explicitly with val or var in the constructor, those values are not accessible outside of the class. You can't access those values from outside of the class. When we do use val and var, this is especially for those of you who are coming from Java or who have done some object-oriented programming in Python or any other language, C++. When I declare my variables in the constructor like this, those variables are automatically state variables. So I don't have to say somewhere in here val description equals description like you would have to do in a lot of other languages. We don't have to do that in Scala. It cuts out some of our typing and just says if you declare these variables in the constructor, I'm going to store them as state variables. I'm going to keep those, I'm going to hang on to those and declare them just like if we declared them down here and set them to an initial value given in the constructor. So a little bit of less typing if you've worked with classes before, a little less typing in Scala, cut down a little bit of our work. So let's see how we actually use this class. So we declared a class, we can use that to define new objects, create new objects on the fly. And we're going to do that by calling the constructor, the item constructor, and using the keyword new. So if I want to create a new object of type item using that class that we just defined, I'm going to say new, and then call the constructor, where the constructor method name is the same as the class name, which is going to be the same as the type that I'm creating. There's a lot to unpack in this one rectangle here, so we'll spend a little time here. So I'm going to call that constructor with my arguments. I want to create an item named cereal that costs $3. That's going to create a new object, set those state variables to the string cereal in the double 3.0, and return a reference of that new item to the caller. Now I'm going to assign that reference to a new value that I'm creating named cereal of type item. So just like we used to have variables of type int, and we still will, variables of type int, variables of type double, variables of type list of ints, etc. What we're doing when we create a class is creating our very own custom type. We can have variables of this type. We can have methods that accept values of that type. We can create instances of that type. We can do anything we could do with ints, doubles, etc. with our brand new type that we define. So we define this new class, this new collection of variables and methods, and now we can use that just like the built-in Scala types. So I'm creating a variable of type item, creating a new item, calling the constructor, and then storing that reference to cereal. Creating another new item called milk, storing that in a value of type milk. Are there any questions at this point? So what we covered right now is a huge chunk of classes and the idea of classes. So let's take a little breather here. Yeah, question?
So the new just adds anything that I class.
So new is going to call, I wish I could have fit the item class on this slide too, but I'll jump back and forth here. So new is going to say, I'm about to call a constructor, and the constructor is this method. The method name is item, and it takes those two parameters. So when I say new, I'm giving Scala a heads up and saying, hey, I'm about to call a constructor. So look through all of the classes that are defined, look for a constructor of this name, and then call it with those arguments. So it's calling this method, which will then create a new object of type item with those initial values that I gave it.
So is it always going to be the case where the type serial is item, that right after you have to do the same data type?
That's a big question there. So the question is, when I create a variable of type item, am I always going to create a new item right after that, or am I always going to assign it an item? The short answer is kind of yes. The longer answer we're going to talk about in 2 weeks called inheritance, where it's not necessarily the case, where I could say, for example, if I wanted a new class named breakfast item, I could have that class inherit all of the properties of an item, and then I could say serial item of type item equals new breakfast item, and as long as it inherits everything, it has all the state and behavior from item, I can still do that. So technically no, but at least for our purposes now, it's going to be yes. Yep.
Every time you declare a new constructor, if you happen to accidentally put the same name, you better.
If I create two classes with the same name?
Yeah, so like if you add another class that also had like items, you set like immediately or just give you error.
Yes, so the question is, if I have another class named item, will that give me an error? Again, the answer is kind of yes. If they're in the same package, it's going to be an error. Or if they're, we have what we call the fully qualified name for a class. I omitted the packages in the slides, but item is in a package named week2.object, I think, item. So that's its fully qualified name, and I can't have another item with that full name. So I can't have another item in that same package. Here, what I did was imported item from that package, and now instead of putting the fully qualified name, I just have item. I can't, even if I have two classes named item in different packages, I can't import them both using this shortcut. If I wanted two different items in two different packages, I would have to use that fully qualified name to specify I want to use the item in this certain package. Which actually gets at the part of the physics homework why I call the vector physics vector. It's because there is a built-in vector class in Scala, and if I call that vector, I've seen it before, I've made this mistake before, a lot of students will use the auto import feature in IntelliJ, import the built-in Scala vector instead of the vector for the homework, and then it just causes all kinds of issues. So it is good convention to try to keep your names separate, even if you are in different packages, just to avoid importing the wrong class and having everything be broken with a pretty hard to find bug. You have a question?
Can you declare an object but then instantiate it later?
You declare an object and then instantiate it later. So you want val serial of type item, and then just leave it at that, and then later on say serial equals new item?
Yeah.
Not quite. You can, so you have to assign it something. In Scala, you can assign it to a wildcard, just the underscore character, and then it'll say, that's your way of telling Scala, I'm going to instantiate this later. I'll assign it something later. And sometimes we'll want to do that. But you can't leave off the assignment completely. You do have to have some assignment, even if it's either an assignment to null or, more preferably in Scala, an assignment to the wildcard. So it's not, like in some languages, we could just do val serial of type item, semicolon, in a language that uses semicolons. And then later on, say serial equals whatever. We can't do that in Scala. You have a question?
Why do you have to purchase twice after? Why do you have to purchase again after on
So I'm doing that to show off the behavior of serial. Well, actually, I think I explained that a little more on the next slide. Oh, no, I don't. Yeah, so let me get into that. Let me talk about that at length. So when I have these two items created, now I can start accessing its behavior and its state in my program. So we have these objects, cool, okay, but what are we going to do with that? So I'm going to simulate somebody purchasing cereal. So say I'm running a store, I got just cereal and milk on my shelves. I don't have any quantities stored, I'm not remembering how much I have, I just know how much has been purchased. So somebody comes up to the cash counter, purchases a box of cereal, I'm going to punch that in my register and say, somebody just bought a box of cereal, and they go on their way. As soon as they walk out the door, I say, let's put that stuff on sale. The first customer is going to be mad, but I'm going to put that on sale. And then another customer comes in and purchases. So I'm just simulating some store behavior. This could be any method calls in any order. So somebody purchased a box of cereal, I put cereal on sale, and then somebody else purchased a box of cereal. And then I'm going to print out how many have been purchased. This times purchased is initially 0, and then each time I called purchased, so for each of those customers, I'm going to increment times purchased by 1. I'm going to add 1 to that times purchased variable. So then when I access this times purchased variable, I should be printing out 2 there. This should be saying cereal has been purchased 2 times. Then I have this other method here just to show that we can use these as arguments and parameters in methods. I'm going to call this print price method, which is going to take an item and just print out what the current price of that item is along with its description. So I can call this with either cereal or milk, and it's going to access the appropriate description and price. And since cereal is on sale, it's going to show cereal with that 20% discount reflected, because that changed in the state of that object. That object's state changed when I made that method call. And I'm going to access that state that has been changed in this next method call. I can also, since price is a var, I can just change price directly. I don't have to mess around with going through some behavior variables, behavior methods. I can just change the price manually if I want to do that, and then print the price of milk, and it'll say the current price of milk is $1.50. And I want to show this example, just to make sure that's clear. Oops, I ran the wrong one. Bear with me. Command or Control plus. Oh, Mac, you got it, Mac. Command plus. So we should get exactly what we expect here. When we print out this line, the first line to be printed, cereal.description is the string cereal, has been purchased 2 times. I called on sale, so the price of cereal has that 20% discount on it, and I purposely used this exact setup to make sure we get a little rounding error here. The price of cereal isn't exactly $2.40. Because doubles lose some precision, we have this trailing 4. The Friday lecture question was actually designed to make sure you're doing this, handling these, but all the solutions I saw, you were all using double equals and still getting the right answer. So I didn't really set it up quite right. So I got to reinforce this. When you're comparing doubles, if I wanted to say, put cereal on sale in a unit test, and then make sure that it equals 240, if I'm using cereal.price equal 240, 2.4 in my unit test, that test is going to fail even if my code is perfectly correct. So when you're comparing doubles, make sure you're taking the absolute value of the difference of the doubles and checking if that's less than some small value, like 1/10,000 usually suffices, or 1/1,000, 1/100,000, whatever you're comfortable with in there. As long as it's small, as long as it's large enough to take care of these kind of errors. So if we're rounding, effectively rounding to here and making sure they're equal, that's how we can effectively and safely compare doubles. I meant for that to come up in the lecture question, so you're not still learning that during the homework. The lecture question missed a little bit, so make sure you're doing this in the homework. When you're comparing vectors, when you have vectors going out to multiple decimal places with some rounding errors, some loss of precision with the doubles, make sure you're comparing them like we did in Friday's slides. Check the slide on doubles and compare them that way. Question? So if you take the that's not the right. The absolute value of the difference, make sure that's smaller than just some small value. Like 1/1000th will suffice. All right, let's get back in these slides. So the important takeaway there, when we create an object of a type using a class, each object has its own copies of every state variable defined in that class. And those states can change in each object independently of each other. So in this example, of course, milk and cereal have different descriptions to different prices, and that's a key point with objects. When we create objects through a class, they're similar, they behave similarly, they have the same variables, but the values in those variables vary independently of each other. They're different copies of each variable, instance variable, state variable, member variable, field, whatever you want to call them. They have their own copies of each one of those variables. These, with the exception of a handful of classes like int, double, char, long, byte, with the exception of a handful, all of these objects are going to be passed by reference. We only have access to references to our variables. This includes the built-in data structures, those types that we've seen, list, map, array. These are all classes. We're going to create objects of those types. And when we move them around, when we either reassign or call a method, they're always passed by reference. And I want to talk about what that means for a little bit here. This is a very crucial point when it comes to references. This was also true for Python and JavaScript, any data structures, the lists, objects, arrays, dictionaries, those are all passed by reference, which may or may not have tripped you up last semester. I think we're careful with the way we make all the assignments so it doesn't trip you up too much. That's not really what we're talking about in 115. We are talking about it in 116 though. So when I create, so what does this mean, this pass by reference? When I create an item when I create an object of type item, name it cereal and give it a price of $3, what I'm doing is creating a new object and storing only a reference to that object in my variable. So this value of cereal, value in this case, my value of cereal only stores a reference to that object, which is effectively instructions of where to find that object in memory. When I call a method and give it that item, I'm giving it a reference to that item. So I'm not making a copy of the entire item and sending it over to this method call like what would happen with an int. An int, you're going to make a copy of that int and send it over. Here, we're sending the reference. We're saying, hey, method, here's the instructions of where you can find my object in memory. Now, when I modify the state of this object in that method, return unit, I'm not returning anything, but I'm modifying the state of that object. That state will be reflected over here in the original cereal variable. because it points to the same object as the reference that I sent to the method. When this method was called here, this method is working with the same object as serial. If I want to create a new value, serial2 of type item, and assign it serial, I'm making an assignment by reference. All I'm assigning is the reference. I'm not creating a new item. I'm just saying item 2 or serial 2, you should refer to the same item as serial. Now when I say increase price of serial 2, increase price gets that same reference. Well, there's only one reference in this entire program, and that was created right here. When I call increase price of serial 2, it has that same reference, that only reference that we've created. We've only created one item, and it's never been duplicated. When I increase this price, well, guess what? The original serial variable reflects that change because they're referring to the same object. It's a good question. So the question is, what's the difference between a reference and a pointer? Off the top of my head, I forget the subtlety, but there's only references in Scala. When you get to C in 220 next semester, C will have pointers and references. You will have to worry about the difference there. In Scala, everything's a reference. We can treat them all the same. And of course, since that reference increased price was called twice, so our price is $3.50 at this point. Right, you would create a new item if you wanted to be different. You would say serial 2 equals new item and create a whole new item. So a few more things about classes. I got two extra things on this slide. One, this applies to regular methods as well, not just constructors, but we can have default values in Scala, which again, if you're coming from Java, Java does not have default values, and you had this method overloading and constructor overloading, which gets to be messy. We don't have to worry about that in Scala. We're going to set default values, and then if any of those values are not used in the constructor call, if they're not given an argument to match the parameter, that default value is used. So if I have the way physics vector is defined in the homework, the default values are all 0. So if I give it all 3, x, y, and z, I get all 3. If I only give it an x, it just zeroes out the other 2. If I don't give it anything, they're all zeroed out. So say I have a 2D top-down game and I only want to use the x and y, I can just pretend that this is a 2-dimensional vector and never specify the z and just have that always be 0. And also the toString method. We'll talk more about overriding methods, but for now, the toString method is a pretty useful one. This gives us, when we print an object of this type to the screen, it'll call this toString method. So if I want custom formatting for a vector, I want this custom formatting right in this vector notation, I can do that through the toString method. If I don't override toString, I get nonsense when I try to print this to the screen. We'll talk about that nonsense later, but it won't give me any really useful information. We will talk about references quite a bit. Here's your second reminder of references. For the homework, and I have this warning in the homework description too, if you're calling update object, you have to store that previous location. That has to be that's the first thing you do when this thing is called. If you're doing dynamic object or whatever you name this parameter, dot previous location equals dynamic object dot location, well, you just assigned previous location by reference. Now when you're updating location based on the velocity, well, you're updating the previous location as well, which is going to break everything. It's going to break your previous location. It's going to break the rest of the functionality you have to write that uses previous location. So this is a big do not do this. Do not do that. That is going to assign it by reference. Previous location, location, refer to the same object. Changes to either will be reflected in both. To get around this, we either want to say previous location equals new physics vector and manually put in the xyz, or say previous location dot x equals location dot x, previous location dot y equals location dot y, and do each dimension separately. But avoid this at all costs. This will break everything, and it's a tough bug to find if you're not used to references and if you're not looking for pass by reference and assign by reference. It's a tough one. I want to make sure that that's very out in the clear so nobody gets really frustrated when they get to that point. If you do get frustrated when you get to that point because you did this, I know what part you didn't listen to. And I will remind you of that too. So classes, I said we have a lot of classes. Everything we did, everything we've used so far every type is a class in Scala. Well, some are objects. Let's not get into that. But the key thing that I want to put in this slide, we did call a constructor for list when we're creating new lists, when we're creating new maps, when we're creating new arrays. We are calling constructors, but just the way that these are set up, they're a little different such that they don't use the keyword new. They have other methods with the same name as the constructor, which calls the constructor inside of there. It'll use the new keyword in there. So when I call this method, it is calling new inside of that method, but it's just set up a little different. So don't freak out, don't panic when you're like, we're creating new lists, but we're not using new. That's just something that Scala has where you can do that. We may or may not talk about that later in the semester. It's not too important. I just want to let you know that we don't always use new when we're creating new objects. Let's talk about access modifiers just for a little bit. You really won't see these in this class. You won't see access modifiers. But access modifiers, first, they're fairly controversial. And the use of access modifiers really depends on what language you're using, and more importantly, the community surrounding that language. Each language has its own community, and those communities kind of agree on some certain standards that you should and should not follow, and that makes a big difference. Also, the design of each language will change things a bit, and access modifiers are something that are really different in each language. But access modifiers in general determines which parts of your code can access which parts of your objects. So if you've coming from Java, you've seen public, private, protected, and if you don't specify your access modifier, it's going to be package private, which means only objects in that same package and classes in that same package can access those values and methods. In Scala, the default is public, which we'll use probably exclusively. I don't think there's any case where I'm going to use the other ones. But there's also private and protected if you do want to use access modifiers. Those do exist in the language. Python doesn't have access modifiers. Everything's just public forever. Java in the community says, let's trust each other. Why are we preventing each other from accessing each other's code? Is the Python community stance. JavaScript, there's no access modifiers. Everything's public, just like Python. But there are some certain workarounds where you can kind of make something private-ish. Not through just a keyword, but there are some ways of doing that. So note this is Java code, but if we were writing classes in Java, the Java community and the way Java is set up, this is what happens if I was teaching Java, and when I did teach Java, this is what I would teach, because it's the Java way, is every state variable is private, and you write a getter and setter, or accessor and mutator for every single state variable. This is the Java way, that's how Java does it, and that's the right way to do it in Java. If you're coding in Java, you're doing this, unless you want to be wrong. In Scala, this is not the case. C++ as well, that's the way you do it in C++. You never let anybody access your state directly in Java. In Scala, we're going to get around that. In Scala, I thought I added a few bullet points on this, but in Scala, when you create a state variable, underneath the hood, Scala does create the getter and setter for you. So underneath the hood, behind the scenes, nobody is actually accessing the state variables directly. This is for any of you coming from Java who are scared that I'm not using access modifiers. The variable is actually never accessed directly. What Scala does is creates the getter and setter and automatically calls the getter and setters for you. And then if you do want some getter and setter functionality, you'll explicitly define the getters and setters that are already being called, but then give them more functionality than what you see here, which was the default. And you can say, look, if somebody's accessing this, call this getter method instead of just giving them the value directly. And same with setters. You can define a setter method, and whenever somebody sets that variable, they'll still do vector.x equals whatever, but it'll call your setter method instead of accessing the variable directly. So there are getters and setters under the hood. Scala, again, just cuts down a lot of our typing, so we don't have to have these getters and setters that do nothing all over our code. So just a note, if you're coming from Java, rest easy. We're not just letting everybody have free reign over our state variables. We do have control over that. It's just built into Scala to not have to do all of this typing every single time. And back to the lecture part.